Everything's working great these days. Okay, so let's make the sine and cosine curves. Okay, so we're going to graph y equals sine and y equals cosine. Now, in this particular book, they like to use this book, or the worksheet you guys are looking at, they like to use x as radians. So when you see x, y equals sine of x, the x is your radians, and this book seems to like theta. So it likes x for radians for an angle in radians, and I will use both. And they like to use theta for an angle in degrees. The applications are really going to be in terms of radians, because the arc length matches up to the angle. Okay. So, all right, what are we going to do? I'm going to take my unit circle, and I've got this thing done in 4 different spots, because for my unit circle, I'm going to have 0, pi halves, pi, and 3 pi halves, and then back to 2 pi. So I'm going to take my circle, and I'm going to unwrap it, and the radians are going to become my x-axis, because there's my angle. So I'm going to put pi halves here, pi, 3 pi halves, and 2 pi. Okay? So what we're going to do is unwrap the circle. So since we're talking about the sine, we're looking for the y values. Okay, and I'll stop and let you catch up. Okay? We're going to graph the sine curve. So what I want to do is graph all of these y values, okay? All of these y values. Now, what we see is the y values are going up and up and up and up, and then all of a sudden the y values start to go down, right? And then the y values get negative, right? And then they're still negative, they come back up again, which matches up to what I have here. So let's make this on this, okay? So here's what I know. 1, negative 1. That's the highest my sine goes, because it's the y values, right? I do know at 0 degrees or 0 radians, the y value is 0. So I'm going to have a point at 0, 0, okay? I know at pi halves, the y value is 1. You guys see that? At pi halves, y value is 1. So we go to pi halves, the y value is 1. At pi, the y value is 0 again. At 3 pi halves, the y value is negative 1. And then 2 pi comes all the way back around, and the y value is 0, okay? At pi fourths, you could put pi fourths in here if you wanted to. And at pi fourths, it's the square root of 2 over 2, but that's about 0.7. So we're just going to go ahead and just, now it's a curve. You can see it from my calculator, right? From my calculator, it's a curve. So let's just make, it is not pointy, it's a curve. All right, that is one sine curve. Now this thing keeps going and going and going like a wave, and in the ocean or a sound wave, and tide keeps going and going and going. But one curve has got this shape. So the one curve, its length is called its period. So its length is called its period. And the length of a sine curve is 2 pi. 2 pi radians. The amplitude is like the height of the wave. If you're out at the ocean and they said, okay, we have 1 foot swells or 5 foot swells, the amplitude is 1, not 2, even though it goes in between, but it goes up to 1 and down to negative 1. So the amplitude is 1. Okay, how's that? Pretty easy? Okay, now the cosine's different. The cosine's different because the cosine happens to be the x values, right? The cosine is my x values. I can put it on the calculator, but let's just get it from the unit circle. So if it's the x value, okay, right here, what's the x value at 0 radians or 0 degrees? What's the x value? It's 1, right? Think about this. At 0 the x value is 1. So cosine starts up at 1. Okay, so let's label this 1. I'm still going to put in my pi halves, my pi, my 3 pi halves, and my 2 pi, okay? Because I'm using the unit circle, correct? So cosine is the x value. At pi halves, the x value is 0. See that? So I'm going to have a point here at 0. Cosine is the x values, and at pi, the x value is negative 1. So I'll have an x value at negative 1. 3 pi halves, it's the x value, and the x value is 0. And then back to 2 pi, the x value is 1. So it's the same shape, it just starts in a different place, okay? So the cosine curve looks like this. They almost look identical, don't they? In fact, they are identical, except for they've just been shifted, right? The cosine curve has been shifted back, okay? So then, again, what's the period? Well, from here to here, it starts to repeat itself, but from here to here, its period is 2 pi. That's the length of one full curve. Because we'll go top of the roller coaster, whee, we get to here, and we do it again, right? So the period's 2 pi and the amplitude is 1, okay? How am I doing? Ready, Spencer? So the amplitude can be modified. If you talk really loudly, you've made the amplitude bigger. It's true. And so we're going to take the amplitude, we're just going to take a sine curve and make it 3 times as tall. And that's the same thing with sound. That's why I did that little example, right? Same thing with sound. So to do this curve, I'm just going to take my sine curve from up above, and I'm going to make it go 1, 2, 3, negative 1, negative 2, negative 3. Same exact sine curve, except it's going to be 3 times as tall. So it's going to look like this. So here's my pi halves, my pi, 3 pi halves, and 2 pi, right? And it's going to go all the way up to 3, and all the way down to negative 3. It looks like this. Oops, I kind of missed there, doggone it. Look at that. Look at that little blueby there. Get rid of my little blueby. I must keep white out and, keep them fiscally good because I obviously use it. Okay, what's the amplitude? The amplitude is 3. The period is still 2 pi, okay? Because it's going to just have that shape. And when we get to 2 pi, we're going to do the roller coaster all over again, okay? How am I doing? Not too bad? All right, then turn the page.
Wait, what did it say for the period?
Oh, the period's still 2 pi. So the width, right? The width, the period, thank you. Okay, turn the page. Now, we can change the period, okay? Now, what this says is we need 2 curves. We need 2 curves in our normal 2 pi, okay? So if I'm going to try and fit 2 curves in here, I'm going to have to squish them up, right? So if I need 2 curves, it's just going to be half as wide. Okay? Well, if the period is normal, if the normal period is 2 pi, right? And this one's going to be half as wide, then the new period, or the width, the new period, or its new width, you can put width down there if it helps you, new width, would have to be pi. So here's my pi halves, pi, 3 pi halves, 2 pi. and I'm going to show you with my finger first, and then I'm going to do it, okay? So a sine, oh, it's a cosine. So cosine curve, watch my finger, goes like this. But now this one we're going to have to go like this. 1, 2, right? So what I do is this shape, these cosine looks like this, and I'm going to draw a picture of it right next to it so you can see this. Okay, this is what a normal cosine shape looks like. Okay, that's a cosine, and it has 5 important points. Its beginning, its end, right? So I got to put this shape right in here. Okay, everybody watch. I got to put this shape right there. Okay, so I'm going to put the beginning and the end. It also has an important point here. That's its middle point, or which is its minimum, and that's got to be in the middle, which is here at pi halves. It also has a point here that goes through the x-axis, and here, which is like 1/4 of the way. So at pi fourths and 3 pi fourths. So one cosine curve, but I need 2. So I'm going to repeat that pattern. Okay, starts here, ends here, halfway through, boom, boom. I'll give you a second to do it. I have 2 cosine curves in the width where I used to have 1. So it's called the frequency. So our frequency is 2 because we have 2 of them, right? How am I doing? And that goes all the way to like radios, and they talk about the frequency of radio. Ever heard that? Frequency of radio? When you change the tune thing, you get a different frequency because you are changing this, which your antenna picks up only the ones that you want it to. When you turn it, you're actually allowing this curve or another curve to hit the antenna, okay? All right, now, 3. We can do this. We're smart. All right, so first of all, before I do anything, I know a sine curve looks like this. I just want to draw it on the side, so I've got a picture of what a sine curve looks like this. My sine curve, sorry, a little mini sine curve. This sine curve is going to be upside down, okay, because of the negative. So, and it's going to have an amplitude of 4, okay? So it's going to look something like this. Okay, upside down. So it's going to be upside down, amplitude of 4, and it's going to be upside down, or it's a reflection over the x-axis. Okay, so I know this. And then its period, okay, its period is going to be kind of weird because we want half a curve. Half a curve. I get the half a curve from right here. I want half a curve. So half a curve means I want just this much of it between 0 and 2 pi. So this thing's going to be stretched out. So I'm going to go pi, 2 pi, 3 pi, 4 pi, right? The sine also has what I consider 5 important points. Its beginning and its end, okay? Now this thing's going to be upside down, so I'm just going to draw a slick old picture of it. I know it's going to look like this. It's going to go, okay? It's going to look something like that, but let's put it in the right places, okay? So I'm going to go all the way down to -4 because of this. So 1, 2, 3, -4, 1, 2, 3, 4, okay? Sine starts at 0 and ends at 0, okay? But between 2 pi, but really that's only going to be half the curve, so it's really going to end way over here, okay? To have half a curve, it's going to go from 0 to 4 pi. It's going to have a minimum here upside down, so my curve is going to look like this. I'll stop and let you look at what I have. I really have half a curve, don't I? That's all I have. It's half a curve because of this 1/2. It's upside down because of the negative, and it goes from 0 to -4. Now I'm going to put the other half in. My pen will work. Okay. And there it is. Now, what's the period of this? What's the period? How wide is this curve? What's the period? What's the period? It's 4 pi. It is. It's 4 pi, so the period's 4 pi. And the amplitude is 4. You don't say -4. It's kind of like an ocean wave. If you ride an ocean wave, when you go down, you say, wow, you know, we've got 10-foot swells, right? It's always a positive value, okay? So now, last but not least, let's take a look at this one. I don't want to look at this one, but let's look at this one, okay? So the question is this a sine curve or a cosine curve? What does it look like? Looks like a cosine curve, or it looks like a sine curve, right? So let's say this looks like a sine curve, so I'm going to start with y equals sine. I agree. What's the amplitude? 1, 2, 3. Get the 3 being there. Now, how do we find this value here? We're going to call it B, which B is the frequency, okay? How do you find B? B is always going to be, or the frequency is always going to be 2 pi divided by the curve width. Okay? Please write that down. B, being the frequency, is always 2 pi. 2 pi because that's the normal period, right? Okay, so if I take 2 pi and divide, what's the curve width? Let's see, hold on, let me get my pen. Curve width, let's see, I'm going to take a roller coaster ride, I'm going to go whee and stop right there, right? It's one ride, and then I go again. So that has a curve width of 4. If I reduce this, I can reduce this to pi halves, okay? So here's my answer to this curve. Y equals 3, because the amplitude goes up to 3 and down to 3, of a pi of sine, come on Bill, sine of a pi halves x. We'll practice this more as we progress, okay? Okay, so the homework, and I'll help you with it, okay? Page 305, 5, 6, 7, 8, 9, 11, 12, and 16, okay?